Hello everyone, my name is Rawan. I have successfully passed Google, Meta, and Amazon interviews. So today we will solve the most asked question from big tech companies, especially Amazon, Google, Bloomberg, and Meta. Here you can see it. It is valid parentheses. I know it's maybe not so hard problem, but it's most frequently faced problems. That's why we will solve it. And as usual, we will not solve it as fast as we can. We try to solve it and practice in proper way how you have to use LeetCode in your preparation for big tech companies. Okay, let's go start it. First of all, as I usually say, you have to reset your timer and you have to always track your time because timing is super important and essential part of the interview. Second one, you have to read the problem carefully and understand it what 100%. For example, here, given a string S containing just the characters, brackets, and like semicolons, determine if the input string is valid. Validness here is defined as open brackets must be closed by the same type of brackets, not different. Okay, open brackets must be closed in the correct order. It means that if it's opened, it should be closed. Okay, every closed bracket has a corresponding open bracket of the same type. Every closed bracket has a corresponding open bracket of the same time. Okay, great, great. And like you have to ask yourself while during your preparation with the lead code as a candidate. Also, you have to answer to your questions as a interviewer. You have act like candidate and interviewer at the same time, as I usually say in my videos. So here I'm asking myself as candidate. Uh, it means that am I correctly get the problem? I try to paraphrase the question. Am I correctly get the problem that it asks us like we given a string of the parentheses and we have to find is it valid parentheses in terms of every open parenthesis should be closed, the order should be preserved, and the opened and closed parentheses types should be the same. Yeah, actually that's true because we like now get it. So I also as candidate can ask interviewer like, can you give me some example? And the interviewer can give like these examples. And here we can see that this is a valid parenthesis. This is also valid. This is invalid because types are different. And this is also valid because if each stuff which is opened is closed. So the next question is like, does it contain only three kind of parentheses? Am I right? Is there or any other like additional kind of parentheses? No, it's only three type of it. I don't find any other, but yeah, mainly three type. So yeah, okay, it is easy. And what's the maximum length of S? Like it can be. Let's go to the constraint block, and we can see that it contains only three of them, right? And it's some reasonable big number, let's say like that. Big 10 power of 4, and can it be empty? No, it cannot be empty. That's good sign, I guess, actually. Perfect, perfect. If n would be like length of the s, it would be like this one. So I have asked everything which I'm interested in. So now I can jump to the theory block, not coding block. First of all, you have to explain your idea to interviewer in order to get it correctly, to explain everything. Maybe you did it or understood it wrongly. That's why interviewer can help you at the initial state. After writing the code, if interviewer tries to help, you just go out of the time. That's why it will not be so beneficial. That's why try to think first of all, then code, not do just jump to the code immediately. Okay. First of all, mm, we can solve this problem as a brute force solution, like finding for each like opening parenthesis, we can find the most uh, closest closing parenthesis, but it will not work. We can just iterate it, and we can iterate with like in brute force. We can like do what we can go run through each parenthesis, and for each parenthesis, we can maybe start closing find the closing parenthesis, but it will not work because like some cases will not work. But here it's obvious that we have to use stack. Stack in a Python can be represented as a array. So if we use a stack, it's like a first in, last out. Yeah, it's like a FIFA. So yeah, or FIWA actually. So if we put in order all the open parentheses here, for example, like this one, then this one. So, and then when we meet like a closing parenthesis, we can pop from it if the same like uh, they have the same kind of if they have the same kind. So yeah, let me clear out. So in this moment of time, I just try to explain and just think in myself. It can be a little bit unclear to interviewer. That's why I'm now trying to clear it for interviewer, and I'm saying that okay, I just finished my I just finished thinking, so I can explain what I'm thinking and how I want to solve this problem. Here, first of all, we want to like use a stack for sure. So in a stack, for example, if we like see open kind of parentheses, any kind, we can append to the stack. So otherwise, else we just if it's closed one, else would be, it means that it's a closed parenthesis. So we have to pop from the stack. But here we have also like a one condition. If like last element of stack, oh actually if stack is empty, then return just false, because there is no any open parentheses. It can be the case, for example can be for this case can be like this kind of, when we meet parentheses closed, there is no any open one, it means the stack is empty, and we can immediately in this case return, I guess, false. Yeah, yes. So the second case, when if a stack has some element, it means that some stack has opening parentheses. Last element which we recently inserted should have, or must have the same type actually. What does it mean? It means that for cases like this one, we can, if it's like this one, then it's invalid for sure. Yeah, so should have the same type. If they don't have, then we have to, if not, then false, like easily. Yeah, so I guess it's finished in a loop. Like we can go through open close, and the last edge case which I can consider is openness. For example, if we have like this one, we have more opens than closed ones. Yeah, so then after loop, our stack would not be empty. Yeah, not be empty, I guess. Yeah, I guess that's the last case. In that case, we have to also return false, I guess. In any other case, if everything goes fine and everything is perfect, every conditions which you have put will not return true false. It means that at the end we have to return the true. So after then, I want to do complexity analysis. While during interview, maybe some interviewer do not allow you to do that, like making some complexity analysis beforehand. They usually prefer do it after the code. But while you're preparing with LeetCode, try to do it beforehand. I will explain why. First of all, by doing complexity analysis, you can assess your solution actually complexity. You can assess your solution and you can compare that solution with the most efficient solution. And sometimes you can came up to the solution which is not so efficient, but it's not so bad. But interviewers sometimes want to see like the most efficient solutions. That's why you have to compare it with the solution block or editorial block. That's why it's super important to make complexity analysis. For example, for time here, we know that we like it can be as it must be assessed. It should not be like the same because you didn't should be like tentatively uh, or like nearly correctly assess a time or space complexity because you didn't write the code yet, so you haven't write the code yet, so that's why it's not super like case you have to exactly assess it, but after solving a lot of problems, it would come like intuitively that you assessing it in the correct way. So first of all, the time complexity in this case, we're just running through the example through the S, I mean, so it will not run two times, I guess. It will, I mean, in one loop, we will not use another loop. That's why it would be just linear, where the n is length of S. So the space would be, we're using extra space because we're using stack. In worst case scenario, our stack would be n, I guess, because in worst case scenario, it can be like this actually, which would be n also. Yep. In this case, everything is open brackets, parentheses, and the length is a maximum n. So in this case, it can be also n. So editorial, we are seeing here that there is some examples. I don't read editorial. I just want to compare time and space complexity here. So do not look at the code. Here it is. It's linear and the linear. There is no any other efficient code. That's why we can verify it. It's the same as asking interviewer like, is it good solution? Do you want to continue with the code, or do you want to me think about the solution in the depths and find more efficient solution? Yeah, and the interviewer says yes, go ahead to the code, and we will see how it works. So now you answer to yourself as the interviewer, yes, you can go to the code section. So here's the code section actually. Let's jump to our solution and convert it to the code. Here it is, stack. We are creating the stack. Okay, do we need anything else? I don't think so. So we can just go through the open and the close parentheses. Oh, also I can maybe create a lib library which will be like for each closed one or opened one. Okay, so its lib would be like some parentheses. Open would be connected to the closed or vice versa. I don't know yet, but I will use it, I guess, at the end, and I will create it while I need it. For now, it's a little bit difficult to think about it. Also, I always like tracking the time, 10 minutes, it's okay. I will put threshold like 18, 20 minutes maximum. So for index and character in enumerate s, it means that we are getting some index and the character. Do we need actually index here? I don't think. Okay, we can just go through the s. Okay, and if our character in like lib, if it's opened, let's say, for example, if we see closed one, then we have to check it with the last element in the stack. That's why it should be closed to open one actually, like this one. Yeah, so we have to create the closed one for open one, and oops, the last one, I guess here is also typo. The last one also would be what, this one? Yeah. Perfect. So closed, 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 opened, 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 everything is perfect. Okay, if it's this one, it means that this is a closed one. Yeah, we have, if it's closed, actually this element works, 3, 1, 3, 2. Yeah, if it's closed, then pop from the stack if it exists. Okay, stack should be pop, and we have to previously check 3, 1 that stack is empty. Yeah, okay, if stack is empty, it means that there is no any open case. We have to return false immediately. Am I right? Yes. And the else condition, if stack exists, we can do actually with like this one, stack exists instead of else if, or if stack doesn't have like any elements, or if it has, it means that it's not empty. It means that we have library character is not equal to the stack last element. Stack last element should be opened one. If this is a closed one, it would go return opened one. If they're not equal, return false. Otherwise, we can just immediately pop the stack. Okay, great, perfect. So else, I would like to write here like a continue actually, and here we can just stack can be append our character. I like this approach rather than else. So, and as a last condition here, it should be like fourth one. It's if stack if the stack has element, it means that it can return false. Actually, we can rewrite it like return also true if everything goes fine, but this block can be rewritten like return stack when of the stack is not equal, is equal actually 0. Yeah, if it's equal to 0, it means that it's empty and we can return true. If it's not, then we can return false. Yeah, perfectly. After writing the code, we can first quickly check if there is any typo or some like problems with the code. So yeah, if character in a lib, it means that lib can be like rewritten like closed to opened. Do not do like any renaming or optimization like while you're writing. Just write the code, then you can do any optimization which you can. For example, as I did, for example, writing, then do optimization if you can, of course. If there's no any stack and the close to open, this is a closed one, then if it's not equal to the stack's last element, it means that there are different kind of parentheses and we can immediately return false. Otherwise, stack should be popped and we can continue. If it's opened, this is the opened case, it means that we can append it. Okay, at the end, we can just return if the length of the stack is 0. Okay, perfect. Let's run through the example, and the next step is run example. Here it is. For example, take open this one, open. Let's take it more like a less more element maybe. Let's take the given examples like this one. This would be fine, yes. So we're using stack. Here it is. And we have a library. So first of all, let's have an index here. We have an index here. Let's asterisk. Yeah, this is our index. First of all, this is opened one. We can include the opened one to the this solution. So then we are going to the next one. In the try to run the code. I mean example code line by line, not as in your idea. Right now I did a little bit mistake. I ran in my head, and for sure you think that you wrote the same as the same like you converted your idea into the code, but sometimes code can have some bugs which you didn't notice. That's why it's super essential to run example line by line. Okay, here it is. The first one we run by line. It's in lib. It's not in lib because it's opened one. Here's only closed one. So we are appending to append. Then we are going to the next one is a closed one. So it's closed. It's in lib. Stack not empty. Or stack not empty. Yeah. Yes, I guess stack is not empty, and we have to check closed open. It means that this close it's this opening, and if there is not equal, there are equal. That's why pop would be happened, and it will get popped. The same would be for this one. Then it will go to close, and the close will like remove it, and the same. I mean, it will go to the same. Okay, if we have like this case. This case, so we have a stack, we have an opened one, so we have also the second one is also would be an opened one, because we go here and we can go to the next. Then we're going to closed goes here, and we can see that it's not empty, and actually the last element is the same. Actually we are popping and continuing to the next element, and it's closed also would be removed. Yeah, everything is fine. Let's go with the if it would be like this one. So when we meet this and open parentheses, I'm trying to find some edge cases maybe. So this one, and we are seeing the like this closed element. We are here, for example, this element closed parentheses. So we are doing what here? Stack is not empty, but the last element is not equal to the because this bracket is not equal to the this closing bracket. So to return false. I guess it's perfectly fine. It's not empty. It means that if it's not empty, we are considering twist, and we have yep. If we have this one, our stack would not be empty at the end, so we will return false here. I guess everything is fine, and let's make time complexity analysis like for sure here. Time and space complexity analysis for sure. Here it is, time complexity we're running one time, so there's no any extra loops and something like that. That's why it's a linear for sure. And the space complexities we assess it, it's correct, I guess. They're equal with the previous assessment, so it would be also linear. So I guess everything is fine. And after it, you have to run the code. And I guess, oops, yeah. of course, after the checking, there is I missed this part. That's why trying doing optimization is a little bit not worth it. Yeah, everything works fine. We can submit. Yep, I guess it beats a lot of stuff. So thank you. If you are interested, try to check out another videos in my channel. Thank you. Bye bye.